Okay, let's solve another problem. We have here the horizontal bar ABC is supported by a pin at point A and two rods with identical cross-sectional areas. The rod at point B is steel and the rod at point C is aluminum. Neglecting the weight of the bar, determine the force in each rod when the force P is 10 kips. And then we have modulus of elasticity of steel and aluminum in the problem. Okay, so to solve for this problem, first one is to draw our free body diagram para ma-solve po natin yung load na mag-a-apply kay steel tsaka kay aluminum. Okay, doing so, let's say this is our bar ABC. Meron tayong pin at point A. So, pag sinabi natin noon na pin connection, ilan yung force na mag-a-apply doon? Meron tayong dalawa. And that is horizontal and then vertical component at point A. Or reaction at point A in X direction and then reaction at point A in Y direction, which is perpendicular and parallel to the surface of the pin connection. And then, point B is here. Meron siyang steel rod doon. So, meron tayong force ni steel. And then, meron tayong force P dito. 10 kips. And then, meron tayong force ni aluminum. Assume that is in tension also. So, that will be our free body diagram. Sulat lang natin yung mga distances. 3 feet, 2.5 feet, 1.5 feet. This is point A, point B, and point C. So kung mapapansin niyo sa ating free body diagram, ang unknown forces natin ay 4. PAL, PST, RAX, RAY. Pero ang equilibrium equations natin ay dalawa, summation of forces and then summation of moment. Therefore, hindi po natin makukuha muna yung PST o yung load applied in steel and aluminum dahil etong system po natin ay statically indeterminate. So, ibig sabihin, kulang po yung equation para makuha yung mga load applied in our steel bar and aluminum bar. So, kailangan pa natin ng isang equation para makuha yun. Saan natin po kukunin yung isang equation? Sa compatibility equation ng ating deformation. So, mamaya natin gagawin yon. So, first one, since ang kinukuha lang naman natin is yung load ng steel tsaka aluminum, magsa-summation of moment lang tayo kay point A para ma-eliminate na natin yung RAX tsaka RAY. So, taking summation of moment at point A equivalent to 0, assuming clockwise direction is positive, yung load sa steel natin, direction is counterclockwise. So, that is negative. PST multiplied by 3. Yung PAL natin, papunta kay point A, counterclockwise also. Minus PAL, a vertical distance of, or perpendicular distance of, a total of 7 feet. And then yung 10 kips sa baba, papunta kay point A is clockwise direction. Therefore, positive moment plus 10 multiplied by a perpendicular distance of 50 or 5.5 equivalent to 0. So, ayusin lang natin equation natin. Therefore, 3 PST, lipat natin sa kabila, plus 7 PAL equivalent to 55. And this is our equation number 1. So, dalawa po yung unknown. Papansin natin. So, para makuha natin yung unknowns natin, kailangan po natin ng isang equation pa. So, para makompute yun, compatibility equations po tayo. Dahil kapag nag-summation of force along Y ka, dadami po yung unknown natin. Hindi pa natin makukuha yung ating PST at PAL. So, yung gagawin nating remedy doon is to draw our deformation system para makuha natin mismo yung ating compatibility equations for the deformations. Okay, analyze natin yung problem natin. Papansin natin yung load P natin pababa. So, yung tendency ulit po nun is hilain po yung system natin o yung steel rod tsaka aluminum rod pababa. So, pag renowing po natin yon, let this be our initial position of bar ABC. And then, since hilain nga pababa ni 10 kips, yung steel rod tsaka aluminum natin, since inassume natin na tension pa, ang tension always ma-elongate. So, nandito po yung point B, bababa po yun, ma-elongate, and then yung point C, bababa din po. So, yan po. Again, mas mahaba po yung deformation aluminum na kinonsider natin since mas malapit po yung load na 10 kips kay point C. So, yan po yung magiging final position ng bar ABC natin. Ano ulit po ito? The deformation of the steel and then the deformation of aluminum. This is 3 feet. This is 4 feet. So, dyan pa lang, we can use ratio proportion para ma-relate natin deformation ng steel tsaka aluminum. And by that, by ratio proportion, we can say that the deformation of steel corresponds to the deformation of aluminum. Equivalent to 3 feet corresponds to this total height or base, that is 7. So, therefore, we can say that the deformation of aluminum, so lang natin dito. Therefore, from that, we can say that the deformation of aluminum, cross multiplication lang po, is equivalent to 7 over 3 of the deformation of steel. Or pwede natin sabihin na the deformation of steel is 3 over 7 of the deformation of aluminum. Either way, parehas lang po yung makukuha nating sagot. But deformation is equivalent to PLAE or PL over AE ni aluminum equivalent to 7 over 3 PL over AE ni steel. Pero ang sinabi kanina sa problem natin, the two rods has identical cross-sectional areas. So, yung area ni aluminum tsaka ni area ni steel, parehas magkakancel lang po. At saka kung mapapansin po natin sa ating figure na binigay, yung length ni steel tsaka length ni aluminum ay parehas lang. So, magkakancel lang din po yun. So, ano matitira po? P over E ni aluminum is equivalent to 7 over 3 P over E ni steel. Therefore, substituting, we can get that the load in aluminum over modulus of elasticity of aluminum given in the problem, 10 times 10 raised to 6 psi, equivalent to 7 over 3. The load of the steel, that is unknown also, over the modulus of elasticity of steel, which is 29 times 10 raised to 6 psi. So, cancel po yung times 10 raised to 6, tsaka psi. I-relate po natin si load of aluminum in terms of the load of steel. Cross-multiply lang natin yung 10, mamumultiply doon. That will be equivalent to 7P. Tama? That is 7 over 3 times 10. 70 over 3 times 29 of the load of the steel. So, simplifying, pwede nating sabihin na PAL is equivalent to 0.8046 of PST. Let this be our equation number 2. Substitute now equation number 2 and equation number 1 para ma-solve natin yung mga loads. So, pag sinubstitute natin 3 PST plus 7 PAL, ang PAL po natin ay 0.8046 of PST equivalent to 55. So, isa na lang po yung ating unknown dyan. Pwede nyo na pong i-apply sa calculator nyo yan. That will be equivalent to, nasa-solve natin, PST equivalent to 6,370 pounds. And then, pag na-compute na mismo yung load sa steel, substitute mo lang to sa equation number 2 natin para ma-compute yung load sa aluminum. So, load of aluminum is equivalent to 0.8046 of 6,370 pounds, equivalent to 5,130 pounds. And that will be the requirements for this given problem.